So, receiving live TV from the ISS with Noel Matthews, G8GTZ. I'm particularly interested in this one because just over a month ago, I was at a presentation by Tim Peake. But, you know, no pressure, Noel, no pressure at all. Noel has, it tells me here on my crib card, always been interested in the microwave bands, having never operated on HF. No wonder he and I have never really crossed paths. He's also a keen amateur TV operator, has been chair and secretary of the British Amateur TV Club for the last 10 years, and operates home-constructed equipment, impressive, on all bands from 50 megs through to 122 gigahertz. Wow. Noel, over to you.
Thank you very much, and good morning. Actually, I ought to update that because I'm now on 134 gigahertz as well, so I'll hold the UK record. Yes, good morning, and spend a little time this morning looking at the ISS in general. I want to talk a little bit about the ISS, just refreshers what it's all about. It's actually fairly current in people's minds because, of course, we had the schools, the contact last weekend with the Girl Guides and the Duchess of Edinburgh attended. So talk about amateur radio on the ISS, otherwise known as ARIS, and what signals are coming down from the ISS, the equipment and the antennas and the challenges of putting equipment up there, and then move on and talk about specifically about ham TV, exactly what is it and how do you set about receiving it. And Tim Peake will feature, actually. There's already a picture of him there. So one of the reasons for that, I was involved in the school's mission when Tim Peake went to the ISS, if you remember, in 2016. I was very much involved in the ARIS team that went round to the 10 schools around the UK doing the contacts. So got quite a lot of footage and quite a bit of knowledge of the Tim Peake mission. So what is the ISS? Well, it's a space station or a habitable artificial satellite in low Earth orbit. And it's been built and maintained by 5 space agencies. So that's why it's international. Not one country owns it or runs it. There are a number of modules which have been put up there over the time by up to 5 space agencies. And it started in 1998. It's apparently the largest artificial body, and it's evolving and coming towards the end of its life. It's like everything, they're trying to put a date on exactly how much longer it will last, but certainly it's doubtful if it would be around in 10 years' time, but quite when the date is going to be, it's not quite sure. And it's very much more a commercial operation these days than it used to be. And you hear on the news about commercial space flight and people going up there on paid missions. So it consists of a number of modules, as I say. The European module is called Columbus, and they're all pressurized, connected together, pressurized. And the most noticeable feature about it is probably the solar arrays, the big golden solar arrays, and that's what you tend to see when people see pictures or take pictures from Earth of the ISS. It's the solar arrays that catch the sunlight. And it's 330 to 435 kilometers above Earth, and it is in a naturally decaying orbit, and so they regularly have to reboost it back up to those orbits. And there's a whole story about the ARIS contact last weekend, because they actually did a reboost a couple of days before the contact, and when they reboost it up, it changes the orbit times. And one of the problems they had with the contact last weekend was that it had a reboost a couple of days beforehand, and so the orbit times weren't quite calculated correctly. And so if you listen to the contact on YouTube, they were fairly late going into the contact And those of you who listen on the Goonhilly SDR probably heard the ISS calling before they made the contact, and then it faded out pretty sharpish towards the end, and that's because of a reboot the day before. The orbit calculation data wasn't quite up to date and accurate. So it is, if they don't do the reboots, it will naturally decline. And amateur radio on the ISS, amateur radio has always been around. First used on the shuttle in 1983. And there's an organisation, it's a pretty loose organisation in some respects, called ARIS, which of course stands for Amateur Radio on the ISS. And their goal really is to reach out and use it as part of the outreach to youngsters, to encourage them into STEM by interaction with radio technology. And the amateur radio contacts, particularly for the schools, are organised by ARIS. They don't just happen, but they're coordinated on an international basis. And ARIS is responsible for getting all of the equipment up onto the ISS, and that is no mean feat in its own right. It has to be very, very heavily controlled by NASA, and in some respects, ARIS are very much at the whim of those agencies as to what happens when. And we'll see shortly that ham TV is unfortunately being affected by external influences, if you like, because the environment is so tightly controlled. So there are 5 agencies who run the ISS. There's NASA, Japan, Canada, European, and the Russians. And one of ARIS's job is to liaise with these bodies, mainly through NASA, and all of the ARIS events that you hear, the schools contacts, for instance, are all run by volunteers, and all of the work done in the States to actually get equipment up to the ISS, or rather type approved and then up onto the ISS, is done by volunteers in NASA. A large number of whom actually work within the space industry, which makes it far easier. And one of the reasons why ARIS is so important is because all of the activities on the ISS are very much scheduled. The astronauts' time on the ISS is not. They don't just go to work when they feel like it. This is a schedule for a typical astronaut's day. They will have activities and exercise and meal breaks, and everything is scheduled down to the last minute. And so the schools contacts in particular are scheduled within that and given a 20-minute slot. So that's why you can't just rely on an astronaut being available. The occasional contact that you hear is when an astronaut in his own free time has popped into the shack. So the occasional unscheduled contacts are very much at the astronaut's whim. So the signals on board the ISS are, at the moment, are packet radio, the SSTV images, the occasional voice contact, which is the ones that the astronauts do of their own free will. There are ARIS schools contacts and also ham TV live pictures. And there he is again, that's Tim Peake back in 2016. And at that time, all of the ARIS contacts were done using an Ericsson handheld. So if you listened during the Principia mission to the Tim Peake contacts, he was using an Ericsson handheld for all of those VHF contacts. But I think it was, in 2020, ARIS did a lot of work to update all of the radio equipment on board the ISS. And so there are a couple of Kenwood 710s up there now. You can't just put a Kenwood 710 up there. It has to be approved and packaged. And also the power supplies have to be interoperable with what's on board the ISS. So a lot of work went into developing specific multi-voltage power supplies to run all of the RS equipment up there. And this here is the 710 and the wiring looms for it. And the first unit was installed in the Columbus module, which I said is the European module. And that one is used as the crossband voice repeater when it's not in use for schools contacts. Second unit was then put into the Russian module, and that's the one that's used for packet radio and also the slow scan events. The ham TV transmitter sits in the Columbus, the Columbus module, or will do. That's where it sits. Outside the ISS, well, it's actually not the ideal place to try and mount antennas. There is a lot of clutter on the ISS. The VHF antennas, you can see it here, is being installed. Is a simple, I think that's probably a quarter wave on 2 meters. And the ham TV antennas, the 2.3 gigahertz antennas, are the patch antenna, which is bolted to the side of the Columbus module. But of course, there's a lot of clutter out there. There's solar panels, there's all of the external elements of the ISS. Plus, when visiting vehicles arrive, that can have an impact. So the radio performance can be slightly unpredictable, and it tends to fly. I use the word fly in inverted commas, but it tends to fly slightly nose down to protect the cupola windows from space debris, which has a bit of an effect so that when it comes up over the west, it will be slightly blocked by the ISS itself, but going out to the east, it tends to be better. But it's amazing coverage. Yes, it's 220 miles up there, so it's fantastic, but it can be slightly unpredictable. As I say, the school's contacts are pre-planned because of the schedules, and they allocate 20 minutes for a voice call. The maximum time you can get on an orbit is 11 minutes. That's horizon to horizon. The actual ISS is visible for 11 minutes. Every year, the space agencies are allocated a number of contacts, which are then allocated around by ARIS. They plan the program for up to 12 months ahead, and a best week is generally identified anything up to 6 months ahead, but the actual day and time of any school's contact is only confirmed 10 days ahead because of the astronaut schedules, and even last minute changes can happen, which was another complication last weekend, as John knows. Due to unforeseen circumstances, they had allocated an orbit which was 120, I think 130. And at the very last minute, that got pushed, so they were on the orbit beforehand. So that's 96 minutes earlier. Two impacts of that. One, the royal household's minute-by-minute planning for the whole day went out of the window, and that's very unusual for the royal household planning to be upset. Normally, the royal household planning is the thing that determines the whole day, but they had to be told that this is the way it's going to be. But the other impact was the orbit was not such a good orbit. The ISS on the planned orbit would have been pretty much overhead, but because it was an orbit earlier, it didn't go overhead. And so it wasn't an ideal situation, and those changes only happened on Saturday morning. So they really had all of their work cut out to make that a success, which it was. It was fantastic. And then, as I say, outside of that schedule, there are voice contacts which can be made during the astronauts' free time. They either go into the cupola and look out of the window and take pictures, or they can, if they've got the license, they can pop into the shack, which is why they don't happen that often. So that really is all of the activities on the ISS and what goes on, the thing I want to talk a little bit more about is the ham TV. And this allows astronauts to transmit live video. It's in the 13 centimeter band, so at 2395 megahertz, so just under the Wi-Fi band, which I'll talk about in a minute. The original unit, you can see here, the blue box, was installed in 2013, commissioned in 2014, and was really available for the Tim Peake missions, which we really made the best use of it for. And a lot of you probably saw the live contacts or have watched the videos on YouTube, and Tim really made the most of that then. Unfortunately, the unit then failed in 2019, and this is when it gets complex, because then the unit failed. They had to try and do some troubleshooting when it was still on board the ISS, which, as you can imagine, is not ideal. So within that busy schedule we saw, they had to allocate astronaut time, and they can only do whatever they've got work processes laid out to do. You can't just say, well, undo the back and get your multimeter out and have a poke around and see how many volts you've got on this test point. It's very much what is laid in the process. And unfortunately, they were unable to repair it. So it had to be shipped back. That in itself is no simple matter, because it had to get onto a cargo manifest of one of the returning ships, or at that time it would have been the Russian modules. So it had to be allocated a space on one of the shuttles. Eventually it got back. It then had to go from the States to Italy, which customs and stuff. Eventually it got there anyway and went to Kaiser Italia, who were the company who built and integrated it in the first place. The actual specifications, 2395 megahertz. The TX power out of the box is about 10 watts, but those of you who've played with any of the bands above 1 gig on 23 SEMS or 13 SEMS will know that you can easily lose a couple of watts in a piece of cable that long. And, you know, this is the problem. And so it's probably going to be running approximately 2 watts at the antenna. Talk a little bit more about that in a minute, why it's different from what it was. The patch we saw on the side of the ISS is a right-hand circular patch antenna. It runs DVB-S, which those of you who know about this stuff will know that it's probably not the most efficient modulation scheme, and we could do better today. It runs 2 megasymbols, which is pretty wide, and it also runs MPEG-2 video with an NTSC input. And so Tim's face doesn't look that clear there. Well, that's because it's not state-of-the-art video, because this was built 15 years ago. But it's still pretty cool, and you'll see that later on. So the current status is that the unit was repaired, and it was sent back to ARIS US in 2023. However, NASA had updated the test specifications from when it was originally shipped to the tests they wanted doing before it went up this time. And so an external bandpass filter had to be fitted, which means that the power output will probably be reduced by up to 3 dB from when it was up before. It was eventually taken back on a SpaceX flight in March, and the original plan that would be commissioned in April/May. Unfortunately, that hasn't happened yet. And the latest we've heard is that in the 5 years that it's been away, some other equipment has been installed in the place where the ham TV equipment was installed. So they used the wonderful phrase, which I can't remember, topology reassessment, I think it was, i.e., we've got to work out where this box can go and still work, so we can then put this one in there, and will it... Yeah, okay. So we are still awaiting. I did this presentation 6 months ago, and it said July in the current estimate, and then I did it about 3 months ago and it said October, and now I've been a bit more. Somebody said I should have put in their current estimate is before the end of the year and not specified. Yeah. But hopefully we'll be able to have some fun this winter. But Graham Sherville, G3VZV, says space schedules always only move that way. Things never happen earlier than they think they would. So, once it's up there and once it's been commissioned, when will it be turned on? Well, we don't actually know, but there are some good sources of information. In 2016, when it was up there, it was mainly used for the ARIS schools contacts, but the transmitter was left on at other times, but there wasn't necessarily any video on it. But it will be added to the AMSAT status page, which is a page that ANSAT run for all of their satellites, and it will appear in there. And they will also, they're pretty good these days at tweeting status updates on the various modules as to whether the packet's on, as to whether SSTV's on. All of this stuff tends to get turned off when there is a spacewalk and EVA happening. And so it will be added to the ARIS schedule, and you will have a fair idea when it is on. So, given that it's back up there and it will come back on, hopefully one of the reasons why you're here this morning is because you are interested what you could do to receive it. So, a block diagram of receiving ham TV. There are two ways. I presume, is that the laser? Which one's? Don't know. Anyway, above the line is the ideal way that you would do it. First of all, you need an antenna, and I will talk a bit more about that. But you will certainly need a high-quality preamp on 2.4 gigahertz. Not that difficult these days. But the golden rule is, which is why it's in red, you need high-quality feeder and as short as possible. Get that LNA as close to the antenna as you can to minimize your losses. And the ideal route these days is that you come down at 2.4 gigahertz. So use probably a satellite line amplifier to give you some gain. Use good quality satellite coax into your shack, where it will go into some receive hardware and be displayed using there's various types of PC software or other software that you can run, all of which is free of charge. So it looks complicated, but it's not as complicated as it looks, and I'll run through the various elements. The other way you can do it, but it becomes more complicated, is the yellow line. If you run a 2.4 gigahertz down converter, you then run an IF frequency into the shack, and then similar sort of background, but you've got a little bit more choice as to which receiver you can run if you do it that way, but it is actually more complex because nobody currently makes a commercial 2.4 gig down converter. When it was up there 10 years ago, there was a Kuhn Electronics made a down converter, and a couple of other people did. As to whether they will or not, I don't know. But certainly if you were starting from scratch, I think I would advise going the direct route and staying at 2.4 gigahertz. The only advantage of going down is that your coax can be, you don't need quite so much gain, and your coax can be thin coax rather than thicker coax. Antennas. It is possible to receive ham TV on a simple antenna. When the ISS is overhead, it is possible to receive it. Like we've all seen videos of YouTube of people receiving the voice on their handhelds in the, just holding it here. There is always a 5-minute window when it's very, very strong because it's overhead. But what they can't do is receive it when it's out at a horizon. And the same goes for ham TV. When it's overhead, you would be able to use a fairly simple antenna, but you would have less than 5 minutes coverage. If you want to go outside the 5 minutes, you really need some gain on your antenna, and you do need to track it. And the dish that a lot of people tend to use is the RF hams dish, which is this dish here. That's 1.2 meter mesh. That's not as big as it sounds. You can generally get away with that without too much planning permission from management. And it's fairly light to track. A Yaesu GR5600 will handle that. That's not a problem. If you start to go too big, you run into another problem. Yes, you've got more gain, but the actual beam width of the dish comes down, and so your tracking has to be much more accurate. Whereas with a 1.2 meter dish, it's probably 5 or 6 degrees, so you've got a bit of room there. The sweet spot seems to be the 1.2 meter. So having got your dish, you then need to do some adopt best practices really for the RF engineering. This is a spectrum analyzer plot taken when the ISS was up, and it shows the ham TV signal on 2395, but it also shows Wi-Fi channel 1 right next door to it. Now, that can be a problem for you, particularly as the satellite receivers that we're using, even if you use a BATC receiver, it's using a standard satellite tuner, and they are designed as wideband receivers. There's no selectivity in those in the tuners. So you do need some good filtering. It's not difficult. The filters are around, either on the surplus market or the designs are around. So a good LNA, preferably with a noise figure below 1 dB and about 15 B of gain, into filtering. Satellite coax, probably not the stuff you buy in B&Q, but the reasonable satellite coax will do. Don't forget you're not transmitting, so you're not worried about transmit losses. Some line amplifier to boost the signal level in the shack. These receivers we're using are designed for use with a satellite LMB, the electronics that goes on the dish of an LMB. Typically, they've got 55 dB of gain in an LMB, so the receivers like to see a nice high noise figure to work properly. It's easy to do. The simple sort of £5 off eBay satellite line amplifiers can be put after a good preamp. And then you feed that into your satellite receiver. So the first word of caution is that standard satellite receivers only cover up to 2.15 gigahertz. So you would need to have a down converter to receive 2395 megahertz. But there is hardware around which covers 2395. So any satellite receiver may work. There was a problem with the ISS transmissions originally, whereby the DVB service information wasn't correct. That has now been corrected, and so in theory, a DVB-S receiver will work, but one of the problems with a typical domestic receiver is that you have to scan for signals. Every time you want to go for a new signal, you all know you have to scan your TV or your set-top box for signals. And the problem is, whilst you're trying to receive the ISS, you've got that 5-minute window, so you can't scan for it beforehand and store it as a memory. And so we don't really recommend using a off-the-shelf DVB-S receiver. Plus, they don't cover the frequency. But BATC do sell a tuner module which will A, cover the right frequency, and B, has got software which is designed specifically to receive amateur signals. And so it's not that expensive. The module you see at the top of the page there Components would cost you around about 70 or 80 pounds, and that will give you a unit which is a USB receiver, and you plug that into your PC or a Raspberry Pi to receive the signals. The actual receivers themselves, as I say, we recommend a receiver that's designed for DATV. We've tested all of our different varieties of receivers now because when the Ham TV was originally on in 2017, we took some recordings, some I&Q recordings. So we've been able to play those back into our current range of receivers and check that they do all work. And so if you buy the hardware or buy the components from the BATC, build yourself a tuner, which is a USB tuner. You can then either run, there is 2 sets of PC software, the original French mini tuner, which you may have heard of, or there is now a thing called Open Tuner developed by ZS6RTG. All of this software is free, so they can be used. Or we have our own Raspberry Pi based receiver called Ride, which is the software is free to download to an SD card, and that will give you this type of configuration. So you just plug your USB card into the Raspberry Pi, and it gives you a set-top box type interface, and that will receive the ISS. However, there's one issue we haven't talked about, and for those of you who've been on QO100, unfortunately the ISS is not at all like the QO100, in so much as QO100 stays there at 26 degrees or whatever it is. 26? Yeah, 26 degrees, and that's it. It never moves. Well, it does move. For those of you who know, it does move within its box, but it doesn't move much. This thing moves at 27,000 kilometers an hour, and as I said, a pass lasts a maximum of 11 minutes, and your 1.2 meter dish has got a beam width of approximately 6 degrees. And so you do need to track it accurately when it's overhead. And this isn't rocket science. The AMSAT boys have been doing this for a long time, and so it's fairly common. The antennas will need to be mounted on the XY rotator, either a homebrew, or most people tend to use the GR5600. And then you run some form of tracking software on a PC. I personally run PST Rotator. It's got the ISS as a satellite. It automatically downloads all the tracking data, and it should be relatively easy to do once you've got it mechanically aligned, which can be a bit of a challenge initially. And so testing your system is the easiest way to check that you've got it mechanically aligned and your system is performing is to look for sun noise. All of the rotator control programs will have a track sun mode, and you should be able to, from the beginning of the day to the end of the day, your rotator should be able to accurately track the sun. Now, if you've got a prime focus dish, which is the one I was using, you can optically see whether it's tracking it, because the feed or the hub at the front should cast a shadow over a boss in the middle of the dish, and that should accurately stay like that throughout the day. With an offset dish, which are the ones with the feed at the bottom, you can't do that. And so the best way to check your system accuracy is to use a noise power meter to measure the sun noise. And you can see 2 or 3 dB out of a 1.2 meter dish, so it's not impossible. The sun is a great tool to check your alignment generally on microwave dishes, and there are either software using the tuner that you've got. You can either use software, or the BATC Portsdown system has got the ability to look at sun. Now this was a recording I took when we were doing ISS initially, and I was tracking. This was the cold sky, came across the sun and went off again, and then set it to auto track. And so you can quite visibly see that, and that tells you two things. One, first of all, over a period of time, is your system tracking the sun accurately? And also, if you should be able to measure the amount of sun noise you're getting, which tells you how good your system is performing. So that's the way to test your system. Once you've done that, you stand a pretty good chance of receiving ham TV. If you've got a local source of digital TV, you can set it so you can see a signal on 2395, and then all you can do is really sit back and wait until ham TV is turned on. So they're the various elements I've talked about: the XY rotator, the dish, the LNAs, into the tuner hardware, and into the software options that you've got for a receiver. I've got 10 minutes, 10 minutes. Yeah, I'll quickly show a video. I won't run it the whole way through. This was the Norwich Schools contact back in 2017. Tim was up there. It starts off initially just showing the standard schools voice contact, but then Tim appears on video, and you'll see the difference. It really does make a difference to have that video contact with him. So I'll just play a couple of minutes of this.
GB1 SS, Golf Bravo 1 Sierra Sierra. This is GB2 CNS, Golf Bravo 2 Charlie November Sierra, listening and standing by for a scheduled contact with the International Space Station.
Hello, Golf Bravo 2 Charlie November Sierra. This is Golf Bravo 1 Sierra Sierra. I read you 555. Harvey, over.
Hi Tim, this is Tim, M6HDJ. Are you ready for your first question? Over.
It's great to be talking to you in Norwich, and yes, I'm ready for my first question. Over.
Hi, this is Maddie. What do you do if you cut yourself really badly in space? Over.
Hi Maddie, good question. We do actually use knives sometimes up here, so we do have to be careful. If we get a really bad cut, then we could actually give ourselves some local anaesthetic and stitch it up with the help of some doctors back in ground control if we need to. Over.
Hi, this is Austin. Are there any protocols or guidance in place if George Clooney comes knocking on the front door, as he did in the film Gravity? Over.
Hi Austin. Well, as far as I'm aware, we're the only 6 human beings in space up here, so if anybody comes knocking on our hatch, I'm not opening it. Over.
Tim, it's Kieran M0XTD. We have you on Ham TV. Give us a wave. Here's your next question.
Hi, this is Sophie. What experiment would you like to add to your mission based on the experiences you have had? Over.
Hi Sophie. I would like to see us doing more of the medical research, investigating some more vaccines and looking into new drug methods as well. I think that's some of the most exciting research we're doing up here. Over.
Hi, this is Max. In what ways does the lack of natural sunlight and fresh air affect you on the ISS? Over.
Yeah, she says he
Hi,
opens
Max.
the windows.
I love opening the windows in the cupola when I'm in Node 3 or in the Japanese module. I love the sunshine coming through the window.
GB1.
Okay. And interestingly, just a point to note, the young guy there who was operating had only got his license 2 days beforehand, and I think that was his first ever QSO. Okay, so that's the story. Scan that QR code. We've got a wiki page which basically tells you everything you need to know, and if it doesn't, let us know what your questions are and we'll update it. So that wiki page will tell you everything that you need to know to get going on Ham TV. If you scan that with your smartphone now, it should, or even on YouTube, it should take you to that link. Okay, thank you very much.
Thank you very much, Noel. Do we have any questions from the audience? Oh. While they're thinking about it, can I ask you, how do you get cables in and out of the space station to all those antennas?
Well, I personally haven't, but I presume there are special cable ducts and actually. So bulkhead connectors onto the bulkheads and which is why the loss is so great or undefinable, really, because nobody's been able to go up there with a bird and measure the power at the. Yeah.
Oh, thank you for that. Nice to have an expert here.
Yeah.
Anything else?
Not ham TV related, but we noticed on that pass, okay, apart from the beginning and end problems, down in the signal faded actually in the middle of the pass as well. Is that normal?
You tend to get polarization rotation as well. That's one of the big problems. The pass on Saturday, Carlos would have been there.
He was
switching the rotation, which captures the changes of polarity. Particularly as it's overhead, the polarization tends to rotate.
Yeah. Okay. Thank you.
Any more? Oh no. Well, I'm sure Noel will be around later if you want to, if you think of something. But in the meantime, Noel, thank you very much indeed.
Thank you.